Can algebra be represented by words? Yes, as the video suggests, algebra in words. Just because we normally use letters such as X and Y doesn't mean that a word can't represent a variable. Similarly, we can change words into variables. For instance, if I told you miles per hour, speed equals miles per hour, that's speed equals miles divided by hours, that's an example where algebra is in words. Miles represents how many miles you've done, 10. Hours represents how many hours you've done, 2. And then the answer is 10 divided by 2, which is 5. So just the same as if you had speed equals x over y or z equals x over y, speed equals miles over hours. It's just another way of doing algebra, but in words. Similarly, I could use m to represent miles, h to represent hours, and s to represent speed. Give me s equals m over h. So when you have a worded lengthy paragraph where they're telling you that something has happened mathematically, you can actually come up with an algebraic equation from it. Now, one of the important things to be able to do this is to be able to read a paragraph and see which words represent the operators. We can often work out which words represent the variables. So, for instance, if I had 5 oranges and 6 apples, the number of oranges, the oranges is one variable, the apples is the other variables. But working out whether it's plus, minus, divide, or times can be a little trickier. So I've put this video has put a little vocabulary list together to show you which words tend to represent which operators. So let's have a look at addition first. The sum of. What's the sum of the cost of a car and a van? So when you see that the sum of, it represents an add sign. So in this case, the two objects would be the cost of the car and the cost of the van. Say it could be represented by C and V. And because it's saying the sum of, it'll be C plus V. And can represent it. I wanted a small box of sweets and a large box of sweets. So S could represent the small box of sweets. L could represent the large box of sweets. So because it says and, S plus L is what you've got. Words such as higher or bigger. So he was 1 foot higher. The on the end of it, or at least the words which represent something larger, represent the fact that you're adding something on. So if you know that somebody's height is 6 foot and you're saying another person was 1 foot higher, it's going to be 6 add 1. And there can be other forms of ER as well. So heavier, for instance. Most of the ones, they can be in the reverse as well. But for now, think of it, if it's getting larger or bigger, then it's adding on. One last one then is also. So also is can represent adding in algebra. So I also ate 5 grams of mint. So I ate 6 grams of mint and also ate 5 grams of mint. That also means add. So it's 6 add 5, giving you the result. So you can see how these are worded paragraphs and yet certain words in them represent adding. In addition is another one. In addition to this, I have 2 dogs. So I have 4 dogs at work. In addition to this, I have 2 dogs at home. 4 plus 2 is 6. So let's have a look at subtract then, taking away. Less. I have 5 less than my friend. So if your friend has 10 oranges and you've got 5 less, that's 10 take away 5. You'd represent that by a takeaway sign. Minus. I was given £10,000 minus the price of a car. So you take 10,000 and take away the price of a car. Remove. I removed 4 of them from my bag. So there were 8 in my bag. I removed 4. 8 take away 4, and that's how many you've got. Ironically, ER at the end of it can represent the opposite, taken away. So when something is getting smaller. So it was 2 kilograms smaller, take away 2. The box was 3 kilograms lighter, take away 3. Deducting. So they made me pay £10, deducting the price of an apple. I would do 10, take away whatever the price of the apple is. Taking away the distance to my house. So I had to travel 40 miles, taking away the distance to my house. So whatever the whole mileage is, take away the distance of the house is 40. Multiplying then. Times. When we say the word times, yes, you usually do 2 times 3 quite often, but remember that when you're saying something's 5 times bigger, we're multiplying it by 5. Double, triple, the double represents multiplying by 2, triple represents multiplying by 3. So the elephant was double the size of the car, multiply the size of the car by 2 and you get the weight of the elephant. The lorry was triple the size of the car, multiply the size of the car by 3, you get the size of the lorry. Lots. Not that there were lots and lots of something, but there were 3 lots of boxes, means multiply the number of the box by 3. Multiply the by 3. So if I had a box of 2 oranges and there were 3 lots of those boxes, the answer is 3 times 2. For every, or per girl, there were 2 hats. So if you've got 6 girls, if it says for every girl there's 2 hats, 6 times 2 is 12. And it's the same with per. The woman was running at 5 miles per hour. If we multiply the number of miles, in this case it doesn't work, but per, as in there were 2 hats per girl, you'd multiply the 2 by the number of girls. So dividing. So when you split something up, you're dividing it. So the group was split into 3. So you're dividing the group by 3 to see how much there is in each group. Shared equally. So the cake was shared equally between 4 people. We're dividing the weight of the cake between 4. And each of the 5 cars had an equal amount of petrol. The combination of each and equal means we can divide it by 5. So those are some words to look out for. You can be given a paragraph, asked to write an algebraic equation from it, or to calculate something using algebra. So you have to be able to recognize those particular words and the ways, phrases in which we can change words in a paragraph into operators and variables in an equation.